Good afternoon, students. So this one is for the lesson of 1.4. So lesson 1.4, the lecture 1.4. Okay, we'll take a look at that. It's all about using the calculator. So what I'm going to be showing you here, it's the way to apply the TID4 or the 84CE, and also the one that you can use for the decimal. So I'm going to show you both. Okay, so we'll take a look at that. So the first one, this one is showing here as f of x, x to the power of 3 minus 225. So you may notice that's a cubic curve. So the way that we put it into the graphing calculator, so now here's what I have for the TID4. It's the same kind of version as the CE model, but the CE model is a little bit lighter and also have a different kind of color. So you can pick the rose gold or, the pink, any kind of color they have. So what we got here, so x to the power of 3. So once you go to y equal, well, if you just turn it on, it's just like a blank screen here. So you want to go to y equal. Okay, let me show the key history as well. You can follow through it. Okay, so let's just clear all this once again. So go to y equals, then you'll see this screen right here. So y1, so that would be considered x to the power of 3. So x, the little caret, that's a power sign. So 3. And now you want to bring down the cursor back here because you want to put in the second term. And for the second term, we do have minus 225. So minus 225, excuse me. So minus 225. Now, if you just simply hit the graph, so this one just gives you the normal window. So the normal window, that shows that from negative 10 to 10 for the x-axis, and then negative 10 to 10 for the y-axis. So what you need to do, so you want to go to zoom, and then I would like to press zoom, and then 0. So basically this feature is just like zoom fit. So zoom fit, that gives you the whole perspective of the graph. So instead of looking at like certain part of the graph here, you're looking at the whole thing. Okay, as you can see that the y-axis, it's pretty thick because that there's no like any specific scale. So we just want to zoom it in. So you may notice that this point here, so that would be the X-intercept, and then here's the y-intercept. And then I'm going to show you how to find those in a minute. So in order to get the X-intercept, you want to go to second trace. And then the 0 here, you want to press 0. Okay, so for the X-intercept, as you can see that once you choose second trace, 0. And the calculator is asking about the left bound. So the left bound is somewhere down below the x-axis, close to the 0. So you want to just move that point, the blinking point, a little bit over to the x-axis, and then press enter. And now the calculator is asking about the right bound. So the right bound should be right above the x-axis. And then you press enter. And that's what we have for the x-intercept. So now, what about for the y-intercept? The y-intercept, you can always do this, because anytime that you find a y-intercept, that means x is 0. So you can always go to second table or second graph. And then over here, you want to change the setting. So second table set or second window. And make sure that the independent variable, you need to convert that to ask. And then for the dependent variable, just leave that as automatic. And go back to second in table again. So press, just put in 0 for x. And then you get a y-intercept. So the y-intercept is negative 225. So now let's do another one. So what we have for this one, so graph y equal y squared minus 9x squared equals 1. So what you need to do first, you want to isolate y by itself. So in order to isolate y by itself, so you want to isolate that 9x squared and 1. So let's just put in 9x squared plus 1 on the right hand side. And then over here, you want to take the square root. So that means y equals plus minus. So square root of 9x squared plus 1. Okay, so we're going to sketch the graph here on the calculator. So we need to put in positive, negative. So going back to the calculator. So again, let me just clear all this. Go to y equal. Okay, clear. So the first one is positive. So in order to put in the radical, so here's the way to do it. So second, square root. See that the blue sign right here, square root, or second, x squared. And now we want to put in the function, which is 9x squared plus 1. So 9x squared plus 1. Okay, bring down the cursor. And now what about for y2? y2 we want to put in the negative. So minus second square root. 9x squared. 9x caret 2. Again, bring the cursor back down here. Plus 1. Now, in order to go back to the default setting for the window, so you want to go to zoom standard. So zoom 6. And as you notice, well, this one, it's a hyperbola. It's a conic section, something that you did in pre-calculus. So it's a vertical hyperbola. Now, what happens if I put it into Desmos? So in order to put it into Desmos, it's pretty much the same kind of process. So for this one, you want to put in y equals square root. You don't want to enter the word. You can just put in that there's a symbol here you can use. Okay, go to the setting. Let's see. Okay, so press the keyboard button here. So you see that square root. Okay, so square root of 9x squared plus 1. So 9x, again, the little caret. Oh, you know what? This one, I need to put it into the blank. Okay, let me start this one over. So again, square root 9x quantity squared. Bring the cursor back down, so just press the right shift or the arrow, the right arrow. And then this one plus 1. Okay, plus 1. This right here, so it's better for you to put inside the parentheses. So once you put in the radical, so parentheses, and then 9x little caret square, right arrow, and then plus 1. So this one is just showing the upper parabola. And then for the minus, okay, let me try one thing here. So for the minus, you can put in y equals negative square root once again. So 9. You can either enter the number or you can just type in that the exponent, 9x squared. And then bring down the cursor back, plus 1. So this one, you just drag the graph here, so you'll see that it's a hyperbola. Okay, so now let's see what else that we have for the rest of this. So the another one, you want to find a point where they intersect. So it's pretty easy to do that on the Desmo, but on the graphing calculator, it might be a little bit complicated. So that's what I'm going to show you next. So again, you need to enter those functions, y1, y2. So one is quadratic, and the other one is linear. And the bracket, this one, it shows the domain and the range, or the window. So anytime they see the setting with the bracket, so that means it's a window, or it's the restricted domain and the restricted range. So this one, basically, that shows the window here. So for the x min, for the x max, this one is the y min and the y max. And I'm going to show you how to change the window on the TID4 and also the Desmo. So now let's put it into the graphing calculator. So we got 3x squared minus 6x plus 1. So clear, clear, and clear the previous function. So the first one, we want to put in the quadratic. So 3x squared. So 3x caret square. Right arrow, bring it back down. So 3x minus 6x plus 1. So minus 6x plus 1. And now for the linear we have 0.23x minus 2.25. 0.23x minus 2.25. Okay, so for the window, we need to change the setting. So you want to go to window, see that X min, X max, X scale, Y min, Y max, Y scale. So the only thing that you need to change is the X min, X max, and also the one that we have Y min, Y max. Okay, so for the window we have, so for the X min it's negative 1, negative 1, 2, 3. So negative, gotta be careful, the negative is the sign down here on the bottom, so negative 1, 2, 3. And then for the Y min, so Y min, would you have negative 2.5, 1.5? Negative 2.5, and the Y max is 1.5. So negative 2.5, and the other one it's 1.5 for the Y max. And now once you're done with this, you want to hit graph. So basically this one is changed to window, and then it shows the parabola, the quadratic function, and the line. Okay, so it looks like this one, the line is not going through the parabola. And now let's find out what else we need to figure out here. So find the points of the intersections. So here's another thing you can use on the TID4. You can always go to zoom. And now this time you want to go to zoom in. Or you can do like zoom box. Let's do zoom in. So see that the blinking point right here? You can always move the point down to the area where you find out the intersection. So just move down a little bit more. Okay, so once you get to that position, you want to hit enter. Now you may notice that I press a lot of down arrow because I want to get that positions close to the blue curve and the red line, and then press enter so we can zoom it in. So once again the parabola, and here's the line. And you may notice that looks like they never intersect. So let's say that you want to get more close look here. You want to press enter again. Press enter one more time. So here we go. So what do you guys notice? So there's no point of intersection. So that means this one, there's no solution. So for the symbol with no solution, that means it's considered 0/. And then on Desmos, so Desmos you want to put in the functions. And then for the Windows setting, you can always go to the setting here. You see that, the graphing setting, the 2 bar. Click that. And then for the x-axis, you can always change the scale. So change those window, the y-x, okay? So once you enter the function, you can always do that. Okay, so now let's look at that, the last one. So find all solutions of the equations with 2 decimal places. So the equation we have here, it's x to the power of 3. Well, you want to convert it back to the normal form, the standard form. So x to the power of 3 minus 4x minus 1. You can always set that equals 0. So basically, we're finding the X-Intercept. We're looking for the X-Intercept here. So let me show the way to do that on the decimal first, because it's much easier. So y equals x to the power of 3. Okay, right click. The right arrow. Okay, let's see what else. The one that we convert to, minus 4x minus 1. So minus 4x minus 1. As you can see that, it's a polynomial. increasing, decreasing, increasing. It's an and curve. And once you click the X-Intercept here, you'll get all the zeros. Okay, so we got negative 1.861, negative 0.254, 2.115. So that's pretty straightforward if you do that on the Desmo. But the bad thing about Desmo, because you're not allowed to use that for the tests. And you're not allowed to use that for any college placement tests. Or in college, once you take math or any kind of science classes, and I'm sure your teacher recommend the TI-84 or the Inspire graphing calculator. So this one is only for the high school setting. So let's say that using it for the SBAG, you're using it for like certain tests or for doing practices, things like that. So now, what about the way to do it on the graphing calculator? So here's the way to do it. Okay, now to look at that. Again, let me clear the window. So clear, all clear, clear. Okay, so we have x to the power of 3, so x caret 3. Again, right cursor. And this one here, we do have minus 4x minus 1, minus 4x minus 1. Minus 4x, and then minus 1. So you want to go back to the normal setting for the windows. Again, zoom 6 or zoom standard. Now for the Desmo, you can just click the X-Intercept, but this one here, you want to go to second, trace, and then the zeros. Okay, so choose 0, number 2. So the first one is somewhere around here, so let's just move the point. So I just click that, the left cursor. So all the way back here, above the x-axis. And then click enter. And then the other one is down below the x-axis. Click that, enter. And then press enter once again. And that's the first 0. It's negative 2.54. And compared to the one that we have on the Desmo, it's the same thing. And then for the other two X-Intercept, you can just follow through the same process. Okay, so let's find another one. So let's say that the one on the left area here, on the left region. So second, trace, and then zeros once again. Now this time we need to shift the point all the way back to the left. Now, since this part is the increasing curve, so we need to start it down below the x-axis. Anything down below the x-axis. So enter, and then right bound. So anything that's right above the x-axis. Okay, click that, enter once again, and then enter one more time. Here we go. So it's negative 1.860806. And here's what we have on the Desmos. Well, this one we actually approximate it, so that's why we round it to 3 decimal places. But this one depends on how many decimal places that you have. You can always come up with the more decimal places. Alright, let's see what else that we have for the rest of this. I guess that's pretty much about it, the way to use the graphing calculator. Do not worry about the rest of this. Alright, so now that's it. That's the lesson for sections 1.4. Alright, thank you for watching the video today. I'll see you next time.